Good morning here in Silicon Valley at 13th Cloud Expo. Good morning, good afternoon, good evening if you're following this day 3 keynote out there on the World Wide Web through SYS-CON TV, embedded into our 2.5 million pages at syscon.com. We are going to be serving up to you today yet another quite long day, for which I make no apologies whatsoever. There is still an awful lot of content to get through, an awful lot of issues to cover. I was monitoring the Twitter sphere yesterday, and I'm sure the gentlemen in this room, thought of all these sessions at Cloud Expo, but I'm not sure we've yet, done privacy enough, and all these sessions at Cloud Expo, and there's not yet been enough said about. Keep those coming, because one, I can have the pleasure of saying, aha, we've got a panel on that, or we've got a session on that. But two, it shows that you're thirsty for coverage. We should cover every possible nook and cranny of cloud computing, big data, and the future of enterprise IT, because that's what we promised you. So please hold us to it. I know that our keynote speaker this morning is going to help exactly that, fill in areas that actually we've not ever had at a Cloud Expo before, so we're quite excited about that. But if he didn't mind, I'm going to take 30 seconds, because I don't have longer before this voice gives out, to do what I did for the other couple of days, which was just to give some data points about cloud computing for your elevator conversations, or particularly when you're talking to your kids and they say, I don't want to hear about your company, dad or mum. I want to hear, some of that cool cloud stuff, so I can pretend to be cleverer than my kids at school. So I just thought, much talk yesterday, I don't know if anyone else noticed that, much talk of Netflix, very often mentioned, right, but never really drilled down into. So I just want to plant this seed in your mind. Netflix is currently the biggest cloud app in the world, if you agree. Now, you might argue about that. If we're on a panel, someone will come back and say, how can you say that thing? But just dwell on this. At peak times, Netflix uses 1/3, or generates 1/3 of all internet traffic. During peak traffic has 1/3, one company, one vertical. So if that's wrong, like I've said yesterday, please take it up with me so that I correct that. But that is my current contention, is that Netflix is the largest, what I would call a pure cloud service on the internet. That was one thing. And then another thing, there was some threads this morning about, usual thing, too many acronyms, and that's completely right and proper. And there was a blog saying, he knows who wrote it because he's sitting in the room. We've got BYOD, bring your own device. And now we've got CYOD, choose your own device. And this is too many acronyms. And oddly, by defining for me CYOD, which I hadn't heard of, I immediately went, oh, that's brilliant. Choose your own device makes perfect sense, because obviously BYOD is hopeless. So this has developed. There's now a nuance that, we recognize multiple devices. Choose your own devices. So I'm unapologetic about all these acronyms, but I did just want to say that another data point, 30% of all workers worldwide are now considered mobile. So a lot of you are employers. You can verify whether that's true or not for you, but, a world in which 37% of everybody you ever have to do with could be classified as a mobile worker. I am certainly one. That means that, for example, if you're a storage play, which is why I'm telling you this, that's 1 billion users right there who are going to need some kind of storage facility. So I will shut up so that Steve Campbell can, whatever the opposite of shut up is. So let's hear about navigating storage in this cloudy environment that we're all taking as a given. And let us please, thunderous morning applause for Stephen Campbell, CTO of HGST. Let's hear it. Very good. Not too shabby. Good luck, sir.
Thanks. All right, thank you. And just to clarify, actually the first thing I'm going to talk about will be what our company is and who we are. But first things first, the lawyers, we have to put this statement up about forward-looking statements. I know you're all fairly familiar with this. I'm going to talk about some things, in the future and so forth, and we're not really obligated to keep everybody updated if things change. That's basically what this says. And I'll move on into our agenda. So I'm going to describe the company. I'm going to talk about our roots, where we come from. And we are HGST. It's not Hitachi anymore. We were Hitachi, and people tend to do that all the time. We were a Hitachi subsidiary, but no longer. So we are just HGST. I'm going to talk a bit about the data center evolution. You know, things are really evolving around us. Netflix is a case where, you know, a huge amount of data being served up versus traditional data centers, which are often captive for transactional banking, et cetera. There's, you know, quite an evolution going on. Two main branches of data centers. I'll talk a bit about enterprise solid state drives, which we're heavily focused on these days. We've been active in acquisitions and adding to our product portfolio, and we see this as a huge opportunity in the data center. I'll talk about a new platform for the future, which is our new 7-platter helium-filled capacity enterprise drive that we've announced this week, and we have a demo in our booth on the floor. I'll talk about that and describe that to you, why we did it, you know, what the benefits are, and so forth. And then talk a bit about some new opportunities for HDD in lower cost, bulk storage, cold storage, areas that are emerging as new tiers in the data center, which are of the largest capacity and really have to bring value for us to all have access to the data that we need. Lastly, I will cover a bit about technology, particularly in rotating magnetic storage, just to describe to you the work we're doing and the areas we're focused on to be able to take areal density or capacity per disk up as we move forward. So HGST, you know, the roots of it are IBM, which is the inventor of the disk drive, was acquired by Hitachi Limited in 2003. And that formed Hitachi Global Storage, which is what we were previously called. Back in 2011, Western Digital announced the acquisition of HGST. It took a year to close the transaction. We did a lot of integration planning during the year, thinking we were going to really integrate the company into one entity. But in the end, the Antitrust Regulation Authority, MOFCOM, out of Beijing, put out a ruling that we needed to hold the two brands separate. So the structure is now WDC as a corporate holding company, with HGST and WD as subsidiary brands independent of each other. So all that planning for integration, we weren't able to actually implement. We are two separate brands, and both subsidiaries are doing well financially and pretty complementary in our product offerings, actually. There is a 2-year time period that MOFCOM set from the close of the deal, so coming up in March will be the 2-year anniversary, and we can at that time reapply to integrate the companies. No guarantees if we can do that, whether they will allow that, but that is kind of the statement on that for anybody who has read or is curious. A lot of people assume that it's just automatic at 2 years. We integrate. Not true. So I'll talk a bit about the heritage. If you look at this graph, this is a timeline left to right of from the very first hard drive invented, which was called the RAMAC by IBM, done right here in San Jose. Huge machine, very expensive, very low capacity. It was the first random access magnetic storage unit. Many key evolutionary and revolutionary technology developments as you go left to right in terms of recording technology, form factors, things like the 1-inch microdrive, which had a short life. But the ones highlighted, like in the lower section there, the first 5-platter 3.5-inch drive, which became the basis of the capacity enterprise storage solution for data centers. That was out of IBM. And we have leveraged that platform forward. We're still making products based off of that platform. It was a real market maker and still is a staple of our product line today. This week we announced in the upper right the helium-filled drive. This is an extension of our capacity enterprise offering, a new platform which adds 2 disks to the platform and has many other benefits, which I'll describe later, subsequent slides. Another area that we demonstrated recently during this year is the 10 nanometer bit pattern media demonstration, where we came up with the lithography and the methodology to actually put patterned magnetic cells on the media where the data would be specifically recorded. This is something we see as very advantageous in the future as we push areal density. Okay. I'm not getting, there we go. Okay, if you look at storage trends, just moving into kind of how things are going in terms of data growth and the amount of data that people would like to store, it's increasing very rapidly, as you can see, and it's broken down into a lot of different places that the data is stored. Down in the lower two sections, those are client. The blue is HDD, the yellow is flash-based client. So these are, like the MacBook Air and thin client PCs. Personal storage is growing a bit above that, which is external drives where people want to take their thin devices, which don't have huge capacity, back up things that they want to personally keep near them in their home or office, and that's growing as well. The cloud, of course, is the most explosive growth in terms of data being generated and stored in the green section. Then on top you have the really mobile devices, and just hearing that 37% of the workforce is mobile. People are carrying around their smartphones and tablets, and having the thin client on top and having all the client PCs and so forth at the bottom are great news for the cloud, because all those people are accessing data through the cloud. In particular, the thinner the client, the more they're going to access things from the cloud and the web. Now, looking at HDDs specifically, areal density growth, or that means the density of the data on the disk or capacity per disk, has traditionally grown quite rapidly, looking all the way back to the 50s and up through. There were years where it was 100% a year, compound annual growth rate. Very, very fast transitions of technology. Of late, it's decreased significantly. It's like 10 to 15% compound annual growth rate, because of the difficulty in the technologies, and the implementations of those take time to mature up and get to the reliability level that is required by the data center and the end user. We're up to a couple million hour MTBFs on our enterprise drives, which is a very reliable product, and we have to be very careful when we introduce new technologies. You can see as you go out to the right, the HAMR, that's an acronym for Heat Assist Magnetic Recording. That will be coming in the 2016 timeframe, and things like that and pattern media that I mentioned on the previous slide will start to bring the rate of increase of areal density back up into the 25 to 30% compound annual growth rate range. Now, that isn't nearly fast enough to absorb the data that's being generated and is desired to be stored. If you look at the upper line, you see 35% compound annual growth rate on data being generated and stored on hard drives. There's a big gap. So basically what we see is there will be more heads and disks, or more average heads and disks per drive. And our 3.5-inch platform with 7 platters certainly gives us the capability to take that on. That platform is just the first in a generation. We expect to leverage that forward multiple generations out up to 10 years, and would bring in all these other recording technologies into that platform to keep addressing that massive growth of data. So the markets are shifting around a bit. There's a lot of growth overall in terms of the data to be stored, and you can look at the list on the right here. Enterprise SSD is the fastest growing in terms of compound annual growth rate. This is the top high performance tier in the data center, where the data needed very frequently and very rapidly would be cached. It's up at the top of the growth. Then personal storage is growing as well. A lot of people still like to have their stuff. When you think about, it's kind of like the shoebox of photos at home. You want to go back and be able to find those pictures. Younger generations are less this way. They're pretty comfortable with things being stored in the cloud. They actually don't worry about it. But people generally have things they want to keep near them, even though it might be replicated in the cloud. Some things they'd like to keep close. Also, as the client or the handheld or mobile device that you use has less storage, you generate a lot of things. You can't keep them all in your phone. You want to put them somewhere and be able to reload and look at things and go back through. Bore your relatives when they come visit with your summer vacation photos and so forth. High capacity enterprise is growing also very rapidly. That's where this 7-platter platform fits in. Massive amount of storage for people. Netflix in particular is a good example, that build their own data centers and have it very specifically oriented to their task. Consumer electronics, gaming, and so forth is growing somewhat. But if you look at desktop PC and mobile PC, they're flat to declining. Not a lot of growth there. All the mobility and the individual users are moving more and more towards thin and light devices, which require less storage. And then enterprise, performance enterprise, which would be 10,000 and 15,000 RPM disk drives, are going to shrink a bit as the enterprise SSD grows, because you can get that high tier performance, and many of the data centers go straight from an SSD to like a 7200 RPM high capacity solution. They don't necessarily all utilize high performance spindles. And then you think about technology. We talk about SSDs. You talk about flash in the PC client and the handheld devices. Traditionally, the rate of increase of capacity, or basically the lithography involved in storing data magnetically, which is the upper blue curve, and solid state through floating gate NAND, have been parallel, and we see that continuing. So there's not a real convergence in the ability to store data, or a crossover point that we anticipate. They're both have been in a extension kind of mode. Perpendicular magnetic recording for disk drives is still being utilized, and as we move forward, we iterate that into a shingled recording technology, which I'll describe in the last part of the presentation for you. And then the next step we move into is heat-assisted magnetic recording, which is a lot of technology implementation and invention required. It so happens that in terms of floating gate NAND, as we move forward to dual floating gate, that's an extension. To get to multi-dimensional 3D and so forth, and on beyond that into future technologies, quite a lot of invention and investment in capital and things that are not mature yet need to be realized to get there. So they're both going through an inflection point of technology. We expect them to remain on a fairly parallel path. So they work in concert. And actually in the data center, when we talk about tiering, you see that they all have their place in terms of the performance level and the value that they bring. Now we'll talk a little bit about the data center. Things have changed a lot. We talked about the growth in data creation. You can see the huge numbers up here, 2.8 zettabytes 2010 going to 40 zettabytes in 2020. So it's a huge amount of data being created, much of which is desired to be stored. In terms of converged solutions, having server networking all converge, that's a huge revenue market. Something that has kind of changed the landscape of the hardware and everything that goes into it, software applications. And then workloads are changing from things like processing records and analyzing data that were kind of a basic thing in the past. We've really gone to distributed processing, virtualization, very dynamic workloads, really things that have to adapt and self-optimize in the data center. And then in the lower right, if you think about time to deploy a new application or a new system in a business, it's gone from what used to be months when you would implement a new system or a modification to your working systems in a company, down to days with virtualization as we converge the network and storage all together into hours, and then with software-defined storage where everything is dynamic, adaptable. People's expectations have gotten to be where you can implement changes in systems in minutes. So things are moving quickly. They have to adapt. They have to self-optimize. Now, when you look at the enterprise market, it's specifically, taking out the client, you can see the capacity enterprise at the bottom as a foundation. In terms of units, is a very large amount and growing very rapidly, served by 3.5. There's a small part that's 2.5 on top of it, also capacity enterprise, but primarily it's served by 3.5. Performance enterprise are the 2.5-inch form factor, 10,000, 15,000 RPM drives. Still playing a big role, still a significant number of units as we move out through 2016. But that is coming down in size slightly. Enterprise on SSD on top, while a fairly small number of units at the present, is growing most rapidly at 47.6%. So we see that all of this has to work in concert. Cost of the actual operation and total cost of ownership is extremely important. And SSDs are becoming a key storage tier at the top, where data would be cached for rapid access and transactional type of access. So talking about the data center and the transition, traditional data centers aren't going away. Many of these are captive. Many are in financial institutions such as banking, stock exchanges, where you need really rapid transactions. There are many applications that need to run on these. However, the workloads are predictable, typically backed up with RAID type systems for protection in case of a failure. And the size of these are terabytes to petabytes. If you look at hyperscale data centers, which tend to be social networking, search type companies, and things like Netflix, they need to be optimized solutions. People tend to do their own data centers, optimizing around the hardware, the tiering, the software and applications that they know they need. The workloads are very dynamic, so it has to be adaptable. Another key is that cost is everything as these things explode in size. So free air environments means, unlike the controlled environment on the other side of the chart, they would like to not have to air condition the facilities. They'd like the products to be able to run over a wider temperature, humidity range, and so forth. And the scale is huge, petabytes to exabytes in these systems. Now, the last bullet, free and forever storage, is kind of interesting because a lot of it's paid for by advertising revenue, all kind of other things that wouldn't traditionally happen in a normal data center in a banking situation where fees would cover it. You know, people feel like it's free. If you talk to young people that expect their email to be there instantly, expect their pictures to be there forever, don't think you really have to pay anything other than the ISP service fee, it's funded in another way. So it's very important for us to get the value and get the total cost down for these hyperscale data centers. So pain points are reliability for a hyperscale data center. We have 2 million hour MTBF on our capacity enterprise. It's something that's actually becoming a standard. Power consumption and cooling costs are huge because in like a 5-year life of a product, the utility bill to run that product and to generate the environment that it needs to run in, cooling the room, are quite expensive relative to the acquisition cost. Then actually the data center, the density and the floor space, getting higher capacity in a unit volume is important, and management administration and adaptability of the converged solutions is very important. So we talked about the growth rate being extremely high and actually outpacing the aerial density, so we're having to take higher capacity platforms and implement new technologies as we move forward. But actually a lot of the data that is now being generated doesn't need to be accessed all that frequently. So a new area called cold storage is emerging, which needs to be very cost effective, or the IT budgets of the companies and businesses won't be able to afford it. So this is a new area that we're all very focused on to try and solve. And I will talk a little bit about that later, some of our thoughts. You think about tiering, I've talked about it a little bit, but at the top you've got high performance solid state drives for hot data. And this is about 10% is what some of our major customers tell us. They think hot data will be about 10% of the total capacity in a data center. So it's there and coexists with the other tiers and work in concert. Warm is the 10, 15K high performance HDDs that we currently ship for data that's actually next level of access expectation in terms of speed and so forth. And then you move down into the capacity enterprise, which are where these 7200 RPM 3.5-inch drives fit. Now the top 3 tiers have been in existence for quite a while. That's really the mainstay of data centers today. But as we move forward, you look down into cooler and cold storage. These are new areas. There are products announced and being shipped cooler, which are often based off of desktop drive technology, lower duty cycle, reliability requirements not as stringent, not as sensitive to that, but cost is everything. As you move into cold storage, this is the newest class that is emerging, and this is where archival type data that needs to be accessed in tenths of seconds versus milliseconds needs to be stored. It needs to be retrieved more quickly than it could be from tape, which could be minutes to hours. So it's a new tier emerging, and it actually is going to be very large in terms of total capacity. Now applications across these segments, if you look at the hot data, this is where things would be cached up that would be needed frequently, searches that would be done very frequently, and a lot of people asking for that data. Also trading, transactional type things, big data analytics where you really want to process things fast to get down to the root cause of a problem or whatever you're searching for, or fit into that. Warm data is, databases, intelligence, cloud gaming, things that don't require that absolute highest performance but do need a significant level of response and performance. Capacity is larger amounts of storage, also fairly frequently utilized. Serving up content like through a service like Netflix fits into that area. An awful lot of the search company data fits into this. That tends to be the bulk of their storage. And then we move into the value in the cooler, where Big data storage, which is like longer tail content. It's aged a bit. It's not needed as frequently as that in the cool area. And then you move to cold, which is things that may never actually be read, but they need to be stored. That could be for some requirement, for a legal thing, for a social media, people's photos, things that they really don't want to lose but won't look at very often. Has to be very cost effective. So if you look at the products that go underneath it, SSDs, certainly for the hot, 10 and 15K RPM drives next, and then 7,200 RPM for the bulk capacity. And then when you move into the value or cooler, they may be 5,400 RPM or different RPM, not as high a performance, lower cost. And then the emerging market being defined is cold storage. And we're not really sure exactly how it's going to go, but we're working hard to come up with a very cost-effective solution for the industry. Now I'll move into enterprise SSDs specifically and talk about kind of where we see things going in terms of growth. The graph on the left is enterprise units. The three colors are the different interfaces, SATA at the bottom, SAS, and then PCIe at the top. So you see that they're all growing, and the total market is growing significantly on a compound growth rate. On the right graph is the revenue projection in terms of growth, and you can see that the SAS and PCI are the real growth areas from a revenue basis. The SATA drives kind of get driven into a value point. There are more units, but ASPs are coming down. In SAS and PCIe, the performance requirements are going up. So these are the premium hot data type devices that will be in the data center. So we're very focused on this as a company. We've announced a couple of acquisitions. We've closed them. We've acquired S-Tech and we've acquired Virident, and also a caching software company called Velobit. So we're putting together a broad SSD product portfolio. This is what's needed in the industry. You do see quite a bit of consolidation in this industry. We've driven a bit of that lately, and I'm personally involved in this pretty closely. So we really see not only the hardware and the broad product portfolio, but software to link it all together and to optimize things and to react to these dynamic workloads. Because really getting the value out of your capital investment is critical. So when you look at our situation as an HDD maker, that part of our business, I talked about the number of heads and disks going up as areal density is slower than the growth. Well, the industry has had a bit of an overage of capital investment in heads and media manufacturing. We now see that needing to be absorbed, which is really good for our business because fixed cost is not something you want to be burdened with. It's the same thing here. Someone puts a data center together. They're not really sure how the workload's going to go. They want something that's kind of modular. They want something that self-adapts, optimizes, and utilizes that hardware very well, because you don't want to have to solve for the peak case and then have a bunch of idle capacity sitting around when people aren't accessing that data. So you want the thing to be dynamic. You want to see the workloads change. You want to be able to add modules at the right tier and have this all come together. So I think resource efficiency is key, low power consumption. All these things come into the actual cost of providing the data from the cloud. This is looking left to right, this is kind of chronological for us. Our first foray into solid state drives was through a joint development agreement with Intel, which has been in place since end of 2008. We've been very successful and continue to be successful and continue to work on products, SAS interface enterprise, high performance. We're the market leader in SAS enterprise SSDs. Then when you move next, just recently we acquired S-Tech, which brought in controller technology, some PCIe products into the product lines, and enhanced our hardware roadmap. Velobit was a small acquisition, a software caching company that actually can take their caching algorithms and we can put it across not only SSDs but go down into the HDD tiers, link that all together. And then most recently we've acquired Virident, which will remain a brand, providing software and flashware APIs to really optimize everything in the cloud, all the way from high performance SSDs down through all levels and tiers of storage. So we see Virident as something, kind of an umbrella that can link all this together and provide a total solution to the cloud data center. And then just product-wise, on the left are the products that came in, the SAS products from S-Tech. The next are the ones Intel JDA SAS products, which we call UltraStar. And then we have the PCIe SSD card products from S-Tech, and then Viridin on the right, which is not only a hardware play, but also has the software, which we expect to link across all of our products. Now I'll describe the helium drive, which there's been quite a bit of news about that this week because we announced it on Monday. We're actually shipping that now and manufacturing in our Asia facilities. So basically it's a product that's fully sealed, so it has to have a seal that can hold helium in. And having helium or a gas that's lighter than air in a disk drive product is not a new idea. It's been around for a long time. It's just very difficult to do reliably. So we've been working on this as a company for more than 10 years. Even back to that 5-platter 3.5 inch that you saw on that timeline early on in the presentation. When I joined the company 5 years ago, we had prototypes running sealed with helium in them on a 1 terabyte 5-platter, and we continued to develop and modify and work to make the sealing effective and to prove it could have a 5-year reliability in our 2 million hour MTBF. So if you think about why we would do it, here's a typical drive on the left is represented with air in it, a 5-platter, spinning at 7,200 RPM, and the one on the right represents a 7-platter with helium. You can see the molecule is bigger of air. You know, the density is 7 times helium. So as the disk is rotating, there's a lot of airflow generated in the disk drive, and there are all kinds of little, if you take one apart, you'll see little vanes and fins to guide the air and try and make it not hit the head. But you can imagine how air at a high velocity causes a lot of force. If you actually think about driving down the freeway in your car, you roll the window down, stick your hand out. You know how that feels, it buffets around, you know, you move it, it's very sensitive to angle and so forth. Same thing's happening here. With a much lower density gas, much less force on the components, much less drag on the disks, much less disruption on the head and the actuator to knock it off track. So not only does it reduce power, which is a major benefit, but it allows us to simplify the mechanism, and we can put in 2 more platters because we don't have all these air vanes and combs and things in there. And also, the disk is more stable, and the head is much more stable in terms of its position. So we can actually position it much more precisely. We can take the track pitch or number of tracks across the disk up, which is capacity. We see this extendable for many generations. It also runs 4 degrees C cooler. And if you look at it on a watts per terabyte basis on this first offering, it's 49% lower in terms of, it's 23% on a drive to drive, works out to 49% per capacity. We see that the air-filled drives, we're going to continue to extend that line, but it will run to a point where we will not be able to take it any further due to the aerodynamics. So the seal platform will continue on, and we can take it up in capacity significantly higher on these thinner disks. So what we do is we add the disks. I mean, we've added up to a 7-platter drive. We put a special cover on it. We exhaust the air and fill it with helium, and then we permanently seal it. Now the sealing is pretty difficult, and it actually does cost some more money. I mean, it costs a bit of money to do it, but at this point in time where capacity is everything, areal density is slowed down, adding capacity, reducing power for TCO are all very important. So we think it's the perfect time to introduce it. I've been pushing it along in kind of an advanced development group for 5 years. And you know, there came this point where we could see the 5-platter is going to be more and more difficult to get capacity. So we decided it was time to do a product off of this. So we've been working on this product for about 2 years. So now introducing it is this week. It's a big rollout. You can see it in our booth over here on the floor, which I think I would recommend people go take a look at it, and I'll talk about that demo in a few minutes. But here, the attributes across the bottom, 50% more capacity at the same areal density, the 23% lower power, and so forth. They're very, it's a very long life platform. I mean, it's a major investment, something we expect to continue all the way out through advanced recording technology implementations. It's not a instead of, it's a lead-in which will be enhanced by other technologies. This is a picture of a cross-section comparing the two. The one on the left is a 5-disc design, which already looks fairly tight when you look at one in terms of fitting 5 disk, 10 heads, and actuator and all that into a 1-inch height. But the one on the right actually has the 7 platters in it. They're thinner platters, and it generates all those positive attributes that we talked about. So in the data center, if you talk about total cost of ownership, it's not only the cost per terabyte of the initial installation, it's the total cost, the life of the product, the power consumption, the utility bill, the cooling, the density and the floor space required. And then, actually there's a multiple on all that, because the less spindles you have, the less processors you have, the less everything you have, the whole thing kind of compounds itself in terms of data center power reduction. So just by comparison, if you look at around 10 petabytes, we used 11 because it came out to an even number of racks and just a nice number of racks. Using 4 terabyte, 3.5-inch, 12 racks, 240 enclosures, 2,880 drives of our 4 terabyte. You can see the power consumption, 32.8 kilowatts. Going to the 6 terabyte, which is just the first implementation of this platform, you can see the reduction down to 8 racks, 1,920 drives, 14 kilowatts that's just the drive power. Less square footage, less cables, less complexity. So it's very significant in terms of its impact. And as we move forward and take the capacity points up, it'll get even stronger. So the hyperscale data center, this is just an example. I mean, you'd have to calculate it yourself for any situation you're involved in, but it was an example that we put together, breaking down the cost of a 5-disk HDD, HDD cost, cooling power, etc. The new UltraStar 6 terabyte, 22 to 33% range on TCO savings, and you can see the HDD cost did go up as a portion of the pie, but pretty much everything else is improved: floor space, cooling power, and complexity. So it provides benefits across many parameters, which we think are very beneficial, and we're very excited to have this product coming out into the market. Now, you think about the square footage of a data center. Some hyperscale folks say, well, we go out and build these things in farm fields, land's cheap, it's not a big deal. But there are a lot of data centers that are in metropolitan areas. They're in fixed square footage. They may have fixed air conditioning capability. This is an opportunity to take your capacity up significantly in the same footprint and have it all fit. So we see it as varied applications depending upon the customer need, how this will be applied. And then you look at new emerging classes of data centers where things are becoming more compact, modular. These container type data centers where everything's built into a container, it's brought in as a module and installed as a chunk of capacity. Physically tighter spacing between the CPUs and the storage. Less room to flow air through to cool. Quite difficult to really get the heat out of these things and have them run reliably, because the biggest, what we use for acceleration of failure rates to prove reliability is thermal is a big one. So the higher temperature things run, the less reliable they are. So controlling the temperature is extremely important. So having the sealed file fully sealed, it can actually run immersed. And there are quite a few people working on liquid cooling for the hardware in data centers. And we actually have a live demo in our booth. There's a clear enclosure with a server with a couple of the 6 terabyte drives in it running under a non-conductive oil cooling fluid. So I'd encourage you all to go take a look at that. It's pretty interesting because you can do this with the sealed file, but any other drive that's utilizing air has a breather filter to equalize pressure and diffusion paths for humidity management and all kind of things, and you can't do this with those products. So as I said, it's a platform, it's a foundation. It's the first point is 6 terabytes, and we see that increasing. We can implement shingle magnetic recording, heat-assisted magnetic recording, and other technologies within the platform. So it's not exclusive to PMR or anything. It's a platform that can take on all the new technologies, which I'll describe in a few minutes. Then thinking about new opportunities for HDDs, and this is this emerging area and basically a big open space in the continuum of tiers from high-performance SSDs out to archival and very slow retrieval from tape. So there's a real access time gap between a capacity HDD and a tape archive. There are needs now for something in between. You know, the capacity HDD and having data stored up to 5 years or more. Big data for medical, so you can search through and really do a lot of your research and records and keep track of things. Legal requirements, compliance requirements for records, financial records, etc. Where you want to get it in, basically in tenths of seconds, not minutes to hours. And so that's a big opportunity that we're working on solutions that bring cost-effective storage to bear. So if you look at the graph on the left, warm to cooler online storage, you know, you can think of, a good example is photos at a wedding. Everybody goes to the wedding, you know, the photos posted online, everybody's excited about it, they all look at the photos, they're really looking at them a lot. Then, you know, it kind of tapers off, then 3, 4, 5 years down the road, someone still wants to see those photos. Not very often, not very many people, but you want to be able to get it in a reasonable amount of time. So that could be an application for cold storage where it's something that people expect to be able to get at, and you know, target of a couple cents a gigabyte for that storage, which is significantly lower than current data storage costs. So we're working actively to solve this problem, provide a solution that's cost effective and meets the parameters of the customer. Now, of course, we're going out and talking to a lot of customers, and there's a lot of input as to where this is going to land. So it's a very interesting time. If you look at tape, tends to be, you know, chunks of data retrieved. Often you have to go retrieve the tapes, put them in drives, and the cycle time to retrieve that data is much longer. And I'll just close out with a little bit on rotating magnetic technology. This is a depiction of shingle magnetic recording. And you can see it looks like shingles. And that's why it's called shingle magnetic recording. Actually, as you take the areal density up, or the track pitch becomes smaller, the smaller and smaller the tracks become, it's difficult to manufacture a magnetic head. It's actually an electromagnet that has to put a field out to actually magnetize the media material in a very specific location for the cells. The ability to get enough magnetic field out of a really small element is tough, and manufacturing a precise smaller and smaller and smaller magnetic element that can do that is also very difficult. So the idea here is you can have a bigger right element, a wider right element than the track, and you can get more magnetic field to fully magnetize the media. But you basically want to have the high track pitch, so you overlap the rights. So the trailing edge of the head as it moves across the disk erases part of the previous track. This is already used in our servo pattern writing. That's how we write servo pattern bursts for quadrature and position information. So it's well known about the characteristics of the edge of an erased track. And we write these in this manner. And then the read head, we can still scale that down. That's not as difficult. The read head is not an inductive magnet like it used to be. It's actually a magnetoresistive element, which can still be scaled down. So the read tracks are still small. You can see the track pitch. The blue is as we read and we move forward. So it gives us the ability to write a better, more permanent record, make it a smaller track pitch, and then read it back with the read head. So this has a lot of applications for sequential data and so forth that make a lot of sense. If you get into a lot of random access in the enterprise, it's not clear how well that's going to work because of the fact that you end up with fragmented records and having to move all around the drive to recover edited files and so forth. So there's a lot of work to solve those problems, but there's a clear application in many large capacity, archival, cold, and all that type of applications. Another one that's following behind it is heat-assisted magnetic recording, and this is to continue taking areal density up. When you look at the disks in a drive, you want a good archival record of that data. You write that data, it's magnetized on the disk. You want that to last. As you make the magnetized cells or the data bits smaller and smaller physically, you have less and less magnetic material magnetized. And as you get smaller, at some point, the media that can be written by a magnetic head has to be fairly soft magnetically, and it can be erased just by normal temperatures. You could take your notebook computer, there could be a point where you take your notebook computer, you put it in your trunk of your car on a summer day, you come back and a lot of your data is gone because of just the magnetization going away due to hitting the Curie temperature of the media. So we have to take the stiffness of the media or the permanence of the record up. Now, when you take the magnetic property to that level, you can no longer write it at normal temperature with an inductive head. So what heat-assisted magnetic recording does is brings precisely located heat through a laser and optics, and there's a plasmonic antenna that transfers the light into heat into the disk and rapidly heats it and cools it. During the time that it's hot, it becomes magnetically soft. The field can write the media, then it cools quickly and becomes permanent. So that's what heat-assisted magnetic recording is. You can see the cycle on the right, which is showing a magnetic curve. So this is coming. It's like 2016 to 2017 implementation. We're all working on it. We have things running with this. We have to work the reliability. We have to prove it all works out before we implement, and we'll do that very methodically. And then bit pattern media. The chart on the left talks about how the media is when you plate the grains and you build up and sputter the magnetic material. They're kind of random little grains. And when you go to write a bit, you write a certain number of grains. They're kind of a rough outline like that. That's what a bit really looks like. We're looking at making it much more orderly and controlled through a lithographic process so that we can really accurately know where they are and make them smaller and have good permanent records. So that's also being worked. The actual lithography isn't done in like a mask that generates that whole pattern. It's a much coarser mask, and then there's a technique called copolymer assembly, where this polymer material is applied in between the far out spaced pattern, and it generates the pattern in between at a very symmetrical level, and that's what we demonstrated and put out a paper on with a 10 nanometer demonstration this past year. Well, all this leads to just talking about the ecosystem and how things are changing. New applications, ecosystem trends are coming. The customer complexity and diversity is huge. There are the two types of data center, basic types, the traditional type with the transactional, often captive, and then those that have a varying workload, social media, search engines, content serving that are coming out. But one thing is clear is that cost is extremely important. So we're really focused on cost, and that's total cost of ownership, including power, cost per terabyte, floor space, cooling, everything that comes into it. And storage is really at the center of this whole ecosystem. Okay, thank you. And we have 2 minutes and 31 seconds for questions.
That's pretty good. Very precise. Can we just, for people who are beguiled by those pretty colored slides, can we just confirm that the slides will be available to us and therefore to everyone? They were some beautiful slides. Let's question Stephen to check that he is really awake as well. Someone just scratched their ear, which you don't need to do, and I've got these mics.
Thank you. Mike Brazzoni, Camp Marketing. There are rumors that storage will consume processors and servers. And then there is also a counterpoint that scale-out servers will be located closer to storage. Which do you see happening, and in what time frame?
Well, I could see, it depends, I think, on who's doing it. I think things getting closer in terms of storage and processing is happening one way or another. And simplification to get reliability and cost make a lot of sense. But different people have different comfort levels with allowing that to happen. Some people really like to keep things separate and really manage it. And I think we'll see how it evolves over time. But you do see things coming out now with storage and processing closer together, co-located. You see things like small cores with the HP Moonshot, doing processing, distributed processing. You could see that being coupled tightly to storage. So I don't have a real strong opinion as to how it's going to go, but we're talking to an awful lot of people to try and figure out what makes sense for us to do. We have a lot of, we have research teams, we have advanced things going on, and to me the biggest challenge, and I had the question the other day, what keeps you up at night? And it was kind of about the helium drive. It's not anything about that. It's more about all the ideas and opportunities to figure out what the right things to work on that will become of value to the customer, to the world. So, we have a lot going on in the company. We've just acquired these companies. We have a lot of new brains. We're trying to figure out how to bring that all together with the input from the customers. So we could use guidance, actually, on that.
Thank you very much.
Any more for any more? Well, personally, I thought that was a fantastic keynote. And if I could clap at the same time as holding a microphone, I would, so I shall. Let's give it up, please, for Steve Campbell, CTO of HGST.